Recording in progress.
Hey everybody, it's March 30th, 2022. This is Computer Science 1 at College of the Sequoias, Introduction to Programming in the C++ language. We just got done learning about how constructors work in structures and classes. We haven't done classes yet, but they work the same there. And we looked at vectors, so I thought we'd do a little project on modeling a line given 2 points. This is a lab we're not doing that I had sitting on the books, and we're going to kind of go along the lines with it. We're going to have 2 points, and we want to model a line, maybe output it as slope-intercept form, and give a method that returns a value of y for any x. So let's take a look at that in our program. I copied and pasted from our other stuff the point structure, and I kept our void display point. Maybe I should get rid of the other stuff though, because we're least familiar with vectors, so maybe we should get rid of the vectors stuff. And just do that stuff from scratch. So don't forget, when we do a constructor, it's helpful to, it's called the same name as the structure. And we're just going to tell it what arguments that go in it for. So let me go over and grab what we're doing. Let me copy that over real quick. Let's grab the whole thing. A line class. Oh, you know what? I don't have to say redesign. I have to just copy everything but that. There we go. Look at that. So, and I'll put that down here. We'll delete it when we're done with it. It's a comment there. Okay, so we need a coded method that calculates and returns the slope. So maybe it says line class. We're going to do a line structure. So what do we need for a line? Let's take a look at the math for it real quick. So I've got 2 points. I've got, let's say, point A and point B. We'll call that XA, XB, or XA, YA. There we go. Screw it. Let's try that again. Point A is XA, YA. Point B is XB, YB. And the information we need for a slope, rise over run. Doesn't matter which one we do, but we got to subtract y's on top. And we need to keep them in the same order for the bottom. So if we do b's first, we got to do on top. We need to do b's the same on bottom. And the point slope form is y equals mx plus b. So that's what we're looking at there. So let's just type that in. So slope, I'm just going to put it in here. M equals y2 minus y1 divided by x2 minus x1. And that's probably not what we're going to use. But once we get it in there, we can figure it out. And B is the y-intercept. So if we're going to base it off the 2 points, we can make a structure. Let's call it struct. We'll call it a line. And maybe we'll call them P1 and P2 for our points. That sounds pretty easy. So we'll want to make a constructor. Our points, we should probably use doubles because the points are doubles up top. But I don't need to put that here. The line is, oh yeah, it's point arg1, point arg2. And maybe we can preset up something. Maybe call this 0, 0. And we can call this one, I don't know, 5, 4. 4 and 3. Let's see. Oops. And that's our constructor method. So this is a property. And these are our methods that we'll have here. Now let's come down and put the method down below. Oops. Undo. I don't even want it there. I want it, put it above the point. And when we do this, first off, we have to scope it. For any method that we have in a structure or class, we got to scope it. And then we also do not want the default settings down here. They do not go in the implementation. They only go in the prototype. So we'll do that here. And what are we going to have in here? Well, the slope and the intercept are points or are values. Maybe we should make values. Well, we definitely need to do P1 equals arg1 and P2 equals arg2. That'll match up with our P1 and P2 up here. So we got to have those in there. We'll think about where we want to put the slope and stuff in a little bit. So we need something that a method that returns the slope. So why don't we call that, like, I don't know, calculate slope, calc slope. And I don't think it needs to take anything in because we've already got the points in the program. But the slope should be a double. So let's bring that down here and prototype that down here, and we'll use what we typed right there. I think we're going to be using that. Again, we got to scope it with line like that. So we've already got access to P1 and P2. And we want the slope to be a double, so I'm just going to set it in there right now. Double M. And then we can work on the calculations here. We want M to equal, I need a parentheses divided by another parentheses. Wow, I didn't want it to close like that when I hit the semicolon, so let me space that out a little bit. So in the first ones, we need the y values. So maybe I'll go p2.y minus p1.y. And then down below, we could do p2.x minus p1.x. That's like our x2 minus x1. And we return m. I don't even need to make a variable, do I? I can just put this right here. Return P2 P2.y minus P1.y over P2.x minus P1.x. Maybe I should put that in another parentheses. And let's get some stuff going here. I left srand in case we want to randomize anything. Let's make point A or first point. And we can prototype that to, I don't know, 6,8. And maybe we'll make our second point. We'll just go with the default. What is our default? Our default 0, 0. We'll go with default 0, 0. And so let's see, what should we get when we do that? Let's come over and look at a picture real quick. So I said 6, 6, or 6, 8, which would be 6 and 8. So m equals rise over run, which should be 4/3. It's going to give us 1.33 if we do that right. If I did that right, that's what it should give us. So let's let's just check it out. So I need to set up my line. My line needs to be first point, second point. I need to call a name here. Line equals my line. There we go. I have a line structure up there, don't I? Oh, I don't need the equals. That's what's wrong. Line, my line. There we go. Line, my line, first point, second point. Okay, so that puts the information in there. So maybe I'll make a double real quick. Double M equals line, or my line, dot calculate slope. And let's just see out testing the line. Current slope M. Let's just make sure everything's working. We'll display our 2 points too. First P dot display, second P dot display, all right, 6800, and we got a current slope of 1.333. So that's working good. Probably don't like the printout there, but we've got a method that calculates and returns the slope. Code a method that nicely outputs the line. It says the model will store the 2 points only. So we don't need to put anything but the 2 points in. So we don't need to make a variable for M and B, so we just leave them as calculations. So maybe we need to calculate y-intercept too, don't we? So let's come back over to the picture and reason out how we get the y-intercept. So one way of doing it is y minus y1 equals m times x minus x1. So let's just rearrange this. We'll distribute the m, and then we add y1. So b here, this is b. So we could code up b, right? B equals negative 1 times m times, it doesn't matter which point we use. Maybe I'll keep that the same. P1 dot x plus P1 dot y. I think that'll work. Let's give that a try. Maybe I'll shrink this down so we can see that at the same time. So let's do that. All right, okay. Let's make a calculate there too. Let's double calc y int. Oops. And we'll do this down below and we'll scope it. And this is in the line structure, so we'll do line. All right, so we're going to need our calculate. Okay, so I'm just typing it out as I see it. I'll refactor in a second. And I want to return B in a second. And so calculating B equals, I got it right there, negative 1 times, maybe I just need to call the calc program, calc slope. Times P1.x plus P1.y. Now we know, since I use 0, 0, that's the y-intercept, y equals 0. So for the problem, the hard code I got set up, my y-intercept, which is b, should equal 0. Well, the y-intercept is technically 0, 0, but oftentimes we just say the 0. So let me try that here and see if that worked. And this is under, well, let me refactor. Let's refactor. And just take this, get rid of that. Actually, I'll just type return here rather than copying and pasting. Oops. And we'll get rid of that line. There we go. Oh, I'm missing that. There you go. So let's see if that worked. It should give me a 0. And this is, we need to do myline dot calc y. And let's put some end lines in there so it looked a little bit better. I didn't like them all on the same line. Current y-intercept is 0. Excellent. Let's come over here and look at some other examples. Let's change our point structures and see what we get. Let's do a 1, 2 and 7, 13. Is that going to be pretty? 13 minus 2 over 7 minus 1. Oh, that's pretty crappy. This is going to be 11 over 6. Let's make this 7, 14. So I get 12 over 6 is 2. And if I calculate my y-intercept, -2 times x is 1 plus 2 is 0. My y-intercept should still be 0 with that. That somehow seems wrong. But oh well, maybe it's right. Let's give that a try. So we're going to change them to 1, 2, and 7, 14. Current slope is 2. That's good. That's good. What happened? So this is apparently we extended it. This would be 0, 0 right here. So maybe if I moved everything up by 2 points, I did 1, 4 and 7, 16. I should still have a slope of 2, but my y-intercept changes. It's now -2 plus 4 would be 2. So let's change it where it's not 0. Make that a 4 and a 16. Slope is 2 and y-intercept is 2. Okay. All right, so we need to calculate a method that nicely outputs the line in the form y equals mx plus b. So maybe we'll call it display line. So we can do a C out. Maybe we should start, I'll start with a new line right here. I like new lines right away. And then we'll say for the points, and then we'll P1, we'll print out the points. P1 display point. I got to scope it. That's why it's not popping up. So that should pop up when I do that. Let's do that. P1 dot there we go. I'm like, why is it not popping up? What's going on? So I'm just doing the 2 points. Let's throw in another. I'm missing the final bracket. There we go. No, I wasn't. Now I got 2. What's going on here? Why is it not like that? Let's just come up here and do line or my line dot display line. And let's see what we got so far. Right now, it should only be doing the points. I don't know why it's got a problem with the double operators. So maybe it doesn't. Maybe it just thinks it does. Nope, it doesn't like something. What doesn't it like? It's sticking with no operator matches that. All right. Let me type it again. Am I doing something wrong here? Do I have the wrong parenthesis quotation mark there? Oh! You can't call a C out in another C out. That's the problem. So we gotta do something like this. That's a little wonky. I don't know that I like that.
Would that be acceptable in our labs?
Yeah, let's see if that works. That's the way you, because these have C outs in them. Oh, that N looks funny. Why does that N look funny? Oh, I got rid of the slash. That would definitely be acceptable. To do a C out that's already, we're trying to do a C out, and it's already a C out. And this was designed to display information. So doing a C out in something that's already designed to display information is perfectly fine. So this top section displays the points. And then we'll come down here and do the actual line. The line in slope intercept form is all right. Nope, we need y. Part of it is y equals, and then I gotta do this calculate the slope. And then we're right now I'm aiming for, I'm trying to get y equals mx plus b. So I've got my y equals, here's my m. I gotta put my x in. And then I don't know if I want to use a plus or a minus. So like let's put plus for now. And we're going to do the calculate the y-intercept. Because what if it's negative? And let's do an end line. I think that's going to work. Let's see how it works. We should get 2x plus 2 for the line we have here. We do. Okay, good. So we got our y equals 2x plus 2. Let's come over here and we had 7 dot. This was 1, 2, and 7, 14 to get the y-intercept as being positive. Let's drop it down to. Let's make it 1, 0, and 7, 12. That should give us a negative y-intercept. That should move the triangle down like this. And so it's crossing below the y-axis, or x-axis. Let's give that a try. So 0 and 12. All right, so I got 2x plus -2. I think that looks a little bad. So I think what I want to do in my code, because I don't like to look like I don't understand how math works. That's basic algebra. That's not like that how they teach us in high school. So we kind of want to look like we know how to do high school math. So like, let's come down here and let's end this right here. And then let's like, what we want to do is, I'll put a little comment here. If b is positive, put plus b. If b is negative, have a minus b. I think having a minus, that looks like I'm saying a minus b. Have minus b. So let's just make a quick b here, and we'll call it calc y. That way we don't have to do it a bunch of times. So maybe I want to put this up at top. So we'll say if b is greater than 0, greater than or equal to 0.
So you're okay with -0 or +0?
Oh, good point. Good point. Extra credit for you. And don't show b if it's 0. I would have figured that out when it looked like shit, I think, if I tested it that way. But I didn't have it set up to test like that, right? So we'll do b greater than 0 first. We want to see out. I already have the space there, so you know what? I'm going to take the space away from here, and we'll put the space in here. And then we'll do an else if b is less than 0. We want to say minus, but I don't like the way it's going to look with the minus right next to it, because it said plus and then the minus was right next to it. So I kind of want to do like minus b, but I want b to be positive. I'm hard coding it up. So I could do -1 times b, -1.0 times b. I think I've got C math already. That's probably the simplest way to do it. I don't need C math for that. I think that'll work. And if b doesn't equal anything, I don't want it to show. If b equals 0, I don't want it to show, right? I don't think I need to do the b equals 0 case. B equals 0 case shows nothing additional, so we can leave this as is. Let's see how it looks. You are so right about that, not wanting to show b equals 0. That looks good, right? I think maybe I want another space in there. I don't like the way that looks. I think I'll add another end line right here. And I don't like that space after the 2 points. So I'm going to do that. Let's see how that looks. Okay. No, I don't. So what else did we have to do? So we need to code a method that evaluates for any x value. So return a. We did those two. We want to code a method that evaluates. So it's got to take an input. It's not taking in one of the points. It's got to take in an integer or a double x. So we want, and it's going to return a double. Eval. Let's just go with eval. Double arg x. So we put in an x, and it returns y from y equals mx plus b. I got a lot of empty space there I don't need. That display line's kind of long. I'm going to put the eval above it.
I have a question on the display on B. If B was 0, would it display anything?
Let's test it. Let's go back to 1, 2. And 7, 14. What did I not finish? Why didn't it like that?
Because B equals the 0, and it didn't have anything to show afterwards. That's how I read the code. It doesn't have an output for 0.
But it shouldn't need it. Run it again. It shouldn't give me an error code. Line 41.
I don't know.
Line 41. Really? Line 89 must return a value. I haven't. Oh, I don't have a return. I'll change that in a second. Yeah, it does. It'll do it just fine.
Okay.
Now, if I had set it up differently, like if I had put the, where is it? Where's my display line? If I had done this X down here, or the MX down here and here, I would definitely want to C out with it.
Okay.
Because here I got the MX is here. If there's no B, I just don't need to go further. That's a good question. All right, so we're evaluating the line. So we're right here. So y equals, so we want to do m times the input and then we want to add the slope. So we can do that all. Hell, I'll make it look like that right here. Y equals, we want to do the calculate slope and multiply it by argx. Oops. And then we're going to add the y-intercept. And I've got that all there. Let's come down here and just put it straight in. And get rid of this double shit right here. All right, so right now we've got and we've got 712 in or 714 in there. This was y equals 2x. That's not showing up very well. Why? It is so dim in my room right now. So whatever we put in for x, we should get twice back in y. So we can just test it here. I'll make a new line here to make it look pretty. When x equals 3, y equals, and I need to do my line evaluate 3. And I should get 6, right? So when x equals 3, y equals 6. Okay, I like that. I like what we got so far. We got something that evaluates. Let's throw some vectors in. Let's make a vector of points. So I'm gonna let's build on this. I think we got that all done. Oh shit! I even said call out my line. Show that your work works with the method with no user interface. All right, we did all that. Now let's upgrade it. I clearly didn't need that. That was just for testing purposes. And let's just create a vector. So we've got a vector and we're going to make it a point. So we call it point. And let's call it XY table. And let's say there's 10 entries. Okay, and let's go through and make a way to populate it. So let's do a for loop. You know what? I don't want to do 10 right there. I'm going to make another thing that says size equals 10. That way, if I want to change it, all I got to do is change it one spot. And we'll do, I guess I got to say int, right? Int I equals 0. I less than size. I plus plus. You know what? I'm going to go 11. I'm going to do 0 and then 5 above and 5 below. So let's say double x. And now I'll use it in here. X equals, when I want to start off with -5, so I'm going to say I minus 5. I think that'll do it. So I'm going to say, I've already got first P already set up. I'll make a new point. Point VP. Vector point. There we go. I like that. Point VP. So we'll say VP dot x equals x. I guess I could go straight to it. How about VP dot? I got a lot. Look at that. X equals 1 equals 5. That was dumb. Maybe we'll call this VPX, and I don't need the other one. Oop. I'm going to say minus 5.0. I want to force it, make sure that it's a double. We'll do negative 1.0 or 1.0 times this one. And I want VP.y to equal, I want it to equal, I need to do, oh shit, what are we doing? We're going to use the line we got up there. So this sets up the line there. Okay, I don't need it down here. Maybe I'll put my line up there as well. So we made our points to make the line. We display our line. Now we're coming up with a table. And we'll call VP.y equals my line. And we turn in VPX. Why does it not like my line? Oh, it wasn't my line. It's my line.eval. My bad. There we go. That explains it. Okay, so in our vector, we wanted to put in points. So I'm going to make XY table bracket I equal to VP. And so we keep remaking VP point. This is going to, like when we go through 0, it's going to take -5, plug it into here, evaluate -5. We've got the function listed over here. That should be -10. So it should get -5, -10. It'll store it in the table as the first component. And then it goes I equals 1. 1 times 1 is 1. Minus 5 is -4. It'll stick in -4 and get -8. So I should be getting -5, -10, -4, -8. And when this goes all the way up to size is 11. It'll be I is 10 is the smallest one. 10 minus 5 is 5, and that doubles to 10. That should do that. Now I just need a way to display my table. And we can do something pretty simple. I don't need a function for it. We'll just go with /t vertical bar /ty. I think that's making my first line. I think I want to throw some end lines in there before that. What I'm trying to do is put a tab, then an X, then another tab. So it's like the table's indented in a little bit. And then I can I don't know how many lines I'm going to need there. So I may need to add more later to make it look pretty. And then we'll see out, we'll do a for loop. And we'll have the same type of loop. We're going to have 11 points. But now we're not calculating it. We're just seeing it out. So I want to see out /t. And then I want to do XY table bracket I. I want to print out the X value here. And then we got another tab. We got the vertical line. We got another tab. And then I want to do XY table dot or bracket I dot Y. I think this is going to work. And we don't need this. That's old news. So the idea here is it goes through and it starts off the table with, does this. And then we got our dot, 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 dashes underneath it. And theoretically, it's going to line up the -5 underneath X and the -10 underneath the Y. And it should do vertical lines like that. And that's so not showing up, and I don't know why. Like it was working better at 2 o'clock when it was dimmer. Let's see if that works. I did a lot of work there without saying a damn thing. I think it could look prettier, but I think it works. I don't think I got enough dashes here. So maybe I will, I'll shift that over some. Let's try that. That's not bad. I clearly don't need this when X equals 3, Y equals 6 line. But we got some vector work in there. We did some constructor. I guess I don't need the do while. And I don't need my Boolean. So here we created a line from 2 points, and then we found a bunch of points along the line. We can always change it. I don't want so many points. I need to stop it from running. I changed the size to 5. Let's see how it looks. So maybe it could be a little bit better if I let the user pick a starting X, right? So here I was starting at -5, and that came in right here. So -5 was my starting X. So if I allow the user to put it in, oh, I got a double X right there. We'll use that right there. I can prompt please enter a value for X to start with. And we can do CNX. And then do a C and ignore. And maybe we could do it how many tables they want, how many different steps they want. And that's size, right? Size is that. And maybe I should say what we're doing. So C out. We already did the C out for the line. So maybe we said let's find some points on the line. Please enter a value for X to start with. And then maybe, and this should already be on a 9. Please enter how many points you want to use. Have on our table. And we'll see in size here. Let's see and ignore. I don't know that I need to see and ignore right here. I think the only time I've ever really needed it is on a string, but I don't think it hurts to throw it in. And what could we do with this? The size is put in, so they picked it. And now I want to put in X right here for wherever they start. That's what we're going to put right there. So let's find some points on the line and make a table. I think that's a little clearer. Let's see. I might be wrong. Let's see how it looks when we run it. For the points 1, 2, and 714, I need some spacing in here. I need some spacing right now. That's bothering me. So let's throw in a couple lines there. And I'll throw in another line here. And I think I'll throw in some C outs right end lines here. Just to get some spacing on the screen. All that text cluttered together is a little hard to read. There we go. Okay, so for the points 1, 2, and 714, the line in slope intercept form is y equals 2x. Let's find some points on the line and make a table of points. So let's say I wanted to start at 3. Nope. Let's get crazy. 2.45. And let's just do, I don't know, 6 steps. And I broke it. So that's not handy. Over here, where was the error? Did it not like my X? An invalid parameter was it's in the vector. So stop. I broke it. So my variables are doubles. Let's see what happened. Let's put in a system pause here. And put a system pause after that table. And maybe here. Okay, so I'm at my first system pause, which is right there. And I hit continue. And I go there and I hit continue. So it's going to go through, let's see, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I know what I did. So I declared my vector to be of size 5 up here, and they redefined size, so I need to change where I make my vector until after they've declared their size. I think that's the problem. I said size 6, and the vector was locked in as size 5. Let's try that. I think that was it. I hope that was it. Oh, I need to get rid of all the C++. I'm doing it now. Let's get rid of the system pauses. And we'll just cut that one in case I want to use it again. There we go. Wait, why did it start at negative? Oh, I think I got minus. I need to say plus right here. Why is my table wrong? So I think the design of the table could use some work depending on how many decimal places they have. But I think we got what we wanted. Y is doubling it. That's based on that line we got. Now we could figure out a way to make the table a little bit prettier, but I think we got a good setup. What do you think?
Looks fine.
It seems fine. Anything else you think we should do, or should we call that a wrap?
I say we call it a wrap.
All right, let's call it a wrap. I will stop recording.
Recording stopped.